Welcome to MCR3U, Introduction to Functions. Just an FYI, this circle is my comfort zone, and this is me. I'm stepping outside my comfort zone. So please be patient with me when I make these videos. Someone once told me to always start with a joke. In this lesson, we will look at domain, range, function, and the vertical line test. You will be able to tell from a graph, an equation, or from set notation and mappings if something is a function. A function is a relation in which each value of the independent variable corresponds with only one value of the dependent variable. Another way of saying that is a function is a relation in which each value of x corresponds with only one value of y. But what might that look like? Let's continue. When looking at a graph, we can decide if it is a function based on something called the vertical line test. The vertical line test is a way to see if at any point in time do you touch the function in two spots, or the relation in two spots. So right now I've got the vertical line on the linear function. So it never hits two spots at once. So yes, the line is a linear function. Moving on to the quadratic, every time I run the vertical line test through, I never hit more than one point. That means it's a function. As a non-example of a function, we can look at the circle. So at the very edge of the circle, I hit 1 point, but as I come into the circle, I am always hitting 2 points. And then at the end, I'm off again. So this one does not satisfy the vertical line test, therefore this is not a function. From equations, we can decide whether it's a function or not if you can find even one value of x that gives more than one value of y. And then when you substitute x into the function, then the relation is not a function. Let's see what that looks like. Here are 4 equations, and we need to decide whether they are functions or not. Looking at the first equation up here, y equals 3x minus 2, we know from grade 9 math that that is the equation of a line, so we expect that it will be a function. I'm going to substitute in some value of x and find out the y. If I let x be 5, when I substitute x equals 5 into the equation where the x was, I put a 5. So 3 times 5 minus 2, and in fact I get one value of y. So yes, this is a function. Looking at the second one, y equals x squared minus 2x. And again, choose x to be y, or 5, and I find that if x equals 5, I put it in for the x here and the x here, and I get 5 squared minus 2 times 5, or 15. Again, I have only one value of y, so this is also a function. In the third one, I've got x squared plus y squared equals 25, and again, I'm going to put in a value for x of 3, and I'll solve for y. So you'll notice as I get down to the end, I end up with y squared equals 16, and when I take the square root of y squared, I get plus or minus 4. So this has more than one value and therefore is not a function. And lastly, we're going to put 4 into this equation for x, and we get 4 equals y squared, and again I have to square root, so I end up with plus or minus 2, so more than one value, so not a function. So from our last two scenes, we know that if we have more than one value of y for an x value, then it's not a function. So if one was 111 and 121, then this would not be a function. But because all of these x values are unique, and then their y values are here, this is definitely a function. Similarly for these ordered pairs, you'll notice that each ordered pair has a different x value and therefore has their own y values. In this mapping notation here, we can see that say Ray, oh, let's not say Ray, Alana goes to 2 y's, or 2 numbers. So this would not be a function because Alana goes to 2 numbers. Let's define domain. Domain is the set of all possible x values for a particular relation. Looking at the graph, we will scan left and right to see where the function begins and or ends. Range will be the set of all possible y values in a relation, and on the graph we will scan up and down to see where the function begins and ends. I'm going to use the blue line to look at domain. So I'm going to drag my blue line across the screen, and if we assume that the line in the graph is going in both directions forever, then we basically can have any x value. And we're going to again assume that it goes off forever in that direction, and then x can be any value. So we write that as x belongs to the real numbers, or x is any real number. Similarly, I'm going to look at the y value. So coming from the bottom, I know that if this particular line goes in both directions, that somewhere down here there'll definitely still be a y value. So y can be any negative number, and coming up here, y can be 0, because here I am, I'm on the line, and if I keep going, y goes off to infinity at the top too. So I can write that as y belongs to any, or belongs to real numbers, or y is any real number. Now looking at this parabola, I'm going to do the same thing. I'm going to move the blue line to check domain and see what values of x I can have. Now assuming again that this parabola goes off in both directions, we know that we can have any value of x, because it'll be out there somewhere, way out there. So we can have any value of x. So x belongs to the real numbers. So it continues across, and that's going to happen on the positive side as well. So it can be any negative number and any positive number. Similarly, moving the red line to represent my range, I come up from the bottom, and you can see down here below the graph, you can imagine if that graph were to extend that there is no function down there. So I still have no function at -5, and at -4 still no function. I don't actually see the function until I'm at -3. So the lower bound of this function would be -3. The function or the parabola does not go below that red line, so -3 is the lowest. And if we continue, again, assuming that the parabola goes off in both directions, it goes on forever, so then y would go to infinity. So we start at -3 and go all the way up. We say then that y is greater than or equal to -3, and y belongs to the real numbers. So this little e here, I've talked about it, or I've used it a couple of times now, but I haven't talked about it. It just means belongs to or is a member of the real numbers. Okay, so this third example, we have a circle, and we already know that it's not a function because it didn't pass the vertical line test, but I can find the domain and range. So moving across here, I have no function out here. If you can imagine that graph paper out there, it's not there. The circle is not to here, which is at -2. So the low bound of the x-axis is -2. Continuing across, the high bound would be +2. So my entire relationship happens between -2 and 2. That's the domain. You'll notice that I had already written the x belongs to r and y belongs to r. That's going to be true for everything in this course. Now I write the domain that x is between -2 and 2, or -2 is less than or equal to x, which is less than or equal to 2. Now looking at the range, I'm going to come up from the bottom, and again there's no function down here or relationship down here, so I go and I reach it at -2. So the low bound for the range will be -2, and the high bound for the range will be 2. We write that as -2 is less than or equal to y is less than or equal to 2. Here are some textbook opportunities. Check the PowerPoint in the hub to gain access to these links that you see here. Your turn, and thanks for listening.